Hello everyone, today I can factor by grouping by finding the GCF of each group and combining the coefficients. So, let's get right to it. Is there a GCF? No. Dots? No. Trinomials? No. Grouping? Yes. Grouping will always have 4 or more terms. In this lesson, it's going to always have 4. So once I recognize that it's grouping, I group the first 2 terms together and the last 2 terms together. I find the GCF of each group. The GCF of the first group here would be x squared. So that would become x squared, x minus 5. And the GCF of the second group, in this case, would be 2. I need to put a sign in between the 2 groups, so I'm going to put plus, since it's a positive 2, x minus 5. Now, these match. They must always match. If they don't match, either you did something wrong, which is most likely, or it just doesn't factor. So now that we did step 1, we found the GCF of each group. Step 2, I combine my coefficients. Since these are like terms, x squared plus 2 is x squared plus 2. And my like term, I keep. I don't write my like term twice. I'll go through a little showing you of why that's the case. So if I have 2x plus 3x, that's 5x. The like terms are x, so I add the coefficients. 2 plus 3 is 5, and I keep the like term. So if I have 2x minus 5 plus 3x minus 5, I'm running out of space here, well, these are like terms. So again, I would combine the 2 and the 3 to get 5, and I would keep the like term. I don't write x twice, so I don't write x minus 5 twice. So here, it's the same thing. I have like terms of x minus 5, so the x squared and the positive 2, I combine them, but since they can't combine, I leave them as x squared plus 2, and again, the like term stays. I only write the like term once. So, either way, that's my answer. Now, before I circled it, I should have asked myself, can I factor any further? GCF, no. Dots, no. Trinomials, no. It is likely or possible that you will be able to factor further when you're using grouping. Number 2, GCF, no. Dots, no. Trinomials, no. Grouping, yes. There are 4 terms. So let's go purple and let's group. The GCF of the first group is x squared. The GCF of the second group is 4. I have to put a sign there, so if it's a positive 4, I put plus 4. Notice when I do that, I end up with the same thing there. That must be the case when you're doing grouping. If it's not, you made a mistake, or it just doesn't factor. That's step 1. Step 2, combine the coefficients. X squared plus 4 is x squared plus 4. Keep the like term, x plus 3. Can I factor further? GCF, no. Dots. Is this dots? Is this difference of 2 squares? Well, x squared's a perfect square. 4 is a perfect square. But dots, difference of 2 squares, must have a minus in between. This one has a plus in between. There's no sots. There's no sum of 2 squares. It can't be factored further. That's your answer. So you always want to try to factor further, but you may or may not be able to factor further depending on if you can, depending on the problem. Number 3. Let's go orange. I like orange. A little twist is going to come up on number 3. GCF, no. Dots, no. Trinomials, no. Grouping, yes. So I group the first group and the second group. GCF of the first group is x squared. Now, here's the little twist on this one. There is no GCF in the second group. If there is no GCF in the second group, I factor out a 1. Because we have to pull something out. So if there is no GCF, I take a 1 out. And you'll see that those match. So from there, we combine the coefficients, x squared plus 1, and I keep the like term, x plus 7. So if there is no GCF of the second group, we pull a 1 out. All right, let's skip ahead to number 5. Just going to do 2 more examples together. GCF no, dots no, trinomials no, grouping yes. So I group the first group and the second group. GCF of the first group is x squared. Now there is a little bit of a twist here. If there's a minus here, we have to factor a negative out of the second group. Otherwise, the like terms are not going to have the same sign and won't be like terms. So the GCF of the second group is 2. So I'm not just taking a 2 out, I'm taking a negative 2 out. So if the middle sign is minus, we have to take a negative out of the second group. Negative 24 divided by negative 2 is positive 12. And notice that these like terms match. Now, same thing as before, I combine my like terms. I combine my coefficients. I bring down my like term. Can I factor further? GCF no. Dots, subtraction, yes. X squared is a perfect square, yes. But 2 is not. So I'm done. So again, the twist for this example, if there's a minus in the middle, you have to pull a negative out of the second group. We're just going to do one more example together. Number 7. In fact, I want you to start number 7 on your own. So please pause, try number 7 on your own, and then unpause. Okay, now that you tried number 7 on your own, GCF no, dots no, trinomials no, grouping yes. So I group them. X squared, x squared, x squared, x plus 5. There is no GCF of the second group, so I pull a 1 out. But since there's a minus here, I pull a negative 1 out. Those match, I'm good. Combine the coefficients, x squared minus 1, keep the like term. Can I factor any further? I keep on asking myself that. The answer's always been no. Well, let's try it now. GCF no. Dots, difference, yes. X squared is a perfect square. 1's a perfect square. It's dots. So I factor further. Dots is always. They do not stop interrupting. So, dots, 2 sets of parentheses, plus and minus, square root of each. Square root of x squared is x, square root of 1 is 1. If you have no idea what I'm doing right now, you go back and you watch the video for factoring using GCF, dots, and trinomials. The x plus 5 just comes down, and that's it. So, grouping is always 4 or more terms. In this lesson, it's going to always be 4. We group the first 2 terms, the last 2 terms. If there's a minus in the middle, you take a negative out of the second group. If there's no GCF, you take a 1 out. Either way, otherwise, you take a GCF out of both groups. These should always match. Once you have that, you combine the coefficients, you keep the like term, and you always want to try and factor further. And often, when you're doing grouping, you will be able to factor further with dots. Have a great day, everybody.